Okay. So, hi everyone. Welcome to the Motor-CAD webinar series. This is our third webinar for Ansys Motor-CAD. So for today, we'll be doing a demonstration for mechanical analysis using Ansys Motor-CAD. So before we go through the demonstration, here are the list of all the Ansys product based on the physics. So for today, we are focusing on electronics product. Inside electronics, we have FSS, Maxwell, SI Wave, iSpec, Motor-CAD, 3D extractor, NoHeads, filter solution, EMA 3D cable, and EMA 3D charge, which is all this. So if you want to know more about all these electronics product, you can go through the Ansys website here, shown here. So for today, we'll be focusing on Ansys Motor-CAD. So for anyone that is new to this Motor-CAD webinar series, I'll be doing an introduction for what is Ansys Motor-CAD. But for anyone who had been to our previous webinar already know, but this will be a refresh for you guys. So what is Ansys Motor-CAD? So Ansys Motor-CAD enables design engineer to evaluate motor topologies across the full torque speed operating range to optimize their performance, efficiency, and size. So Motor-CAD is a template-based design tool for multiphysics analysis of electric motors. And what are the template available in Motor-CAD? These are all the available motor types, which is the brushless permanent magnet motors, the brushless permanent magnet outer rotor motors, synchronous reluctant machines, switch reluctance motors, synchronous machine, induction machine, single phase induction machine, permanent magnet DC, and finally the claw pole machines. And what are the analysis that can be done using Ansys Motor-CAD? All these three, the magnetic, electromagnetic, thermal, and mechanical. So we already go through this electromagnetic and thermal analysis from previous webinar. So for today, we'll be doing the mechanical analysis of stress and displacement in rotor during operation. And now, for the demonstration, we are using the template for BPM motor, brushless permanent magnet motor. So these are the all the parameter for the stator and the rotor, and also for the parameter for the radial and axial dimension here. So, and then for the input material, we'll be using the M250 350 metal here. These two we'll be using this for the stator and the rotor. And then for the calculation, this is just a very simple change, which is the shaft speed here in the drive. So these are the shaft speed that we'll be using, 1,200. And after we analyze it, after we solve it, so we'll be getting the result, which is the von Neumann stress, SVM here. So we'll be checking this result after this. And we also can see the output data for the rotor stress here, the shaft speed, the rotor elimination speed, and the rest. Okay. So without uh, wasting any more time, I'll be go through all the steps that we need to do in order to analyze this mechanical analysis. So let's open our Ansys Motor-CAD here. So this is the a blank one. So we'll be using the version 2023 R1 here. So firstly, what we're going to do is let me open back the. So we change the parameter first. No, actually, what we're going to do is we what motor type we're using. So we already use this BPM here, and for the model, we want it to be a mechanical model, and then for the parameters, we are using the parallel tools here, and for the rotor type here, we're using the V interior V simple. Now we are I'll be changing all the parameters based on the slide that I've shown. Okay, 198, 134.5, 21, 2, 1, 3, 57. And then the pole 8, 0, 1, 6, 17, 0, 16, 150 here, 2, 2, 0.5, 2, 1, 0.2, and 80. So after we change all this, we click on the redraw here. So this is the design based on this parameter. So if you want to know what is a slot number, so we actually can right click this. So anything that moves in this template, that's the thing that we are changing. Like for example, that for slot number, if I right click this, so the slot number will be moving, indicate that we are changing that. Same goes to the stator and diameter here, the stator base. Okay. So after we changing all this radial geometry, we change to axial. So for axial here, we are changing the 260, 160 here, 150, 80, and 50. So yeah, here the same. Anything that we change, it will move here. Okay, we will right click this. So these are all the change that we need to for the parameter of the axial. And then after we set the design template here, we go to input data here. Before that, we can see the 3D design of the motor, the BPM motor here. So if you want to like see or show, you can click or unclick this. This one, yeah. We want to hide the windage, we unclick this. So you can see it. And it is also color coded. So, okay. These are the 3D view. Next, for the input data. For the input data, we are changing the back iron here to 250 35A. And this will change as well. And we're also changing the rotor, changes to 250 to 25 25A here. So you can change all the materials in this page. And then next, after we set the material, we go to the calculation. So for the calculation, we just change the shaft speed into what's the speed you want to observe. So for this, I want to be 1,200. Let me check that. Actually, we want this in 12,000. Okay. And for the magnets, we include the magnets with an adhesion factor of 0.2. So now we can click on the soft rotor stress model. So after we click this, so these are the result. You only take less than 5 seconds to show the result. So after we click on the soft rotor, it will go to this stress tab. So we can see the shading. For the shading, we want it to be the mechanical stress. And we want to see the volume stress here. And we want to see mesh. So we click on this mesh. So we can see all the results for the volume and stress. And for meshing, this is auto mesh, so you don't need to stress your head on how to mesh it properly, but because it is automatically mesh for you. And you can see the result here. This is the part with the most stress indicate here, the red zone here. Also, here and some of here. These are all the parts with the highest stress. And we also can see this is the analytical result for this Motor-CAD, but we also can see the numerical result, which is this output data for rotor stress. So in this simulation, we can see the shaft speed, the material yield stress here, the lamination stress, average and max, the yield stress ratio here, the lamination safety factor here, and the lamination hook stress inner and outer here. And we also can see the elimination, displacement, average, and maximum. So yeah, that is it. This is a very simple simulation demonstration for mechanical analysis. So uh, I hope you guys enjoy it. And if you have any question, uh, you can ask me now, or maybe if you have other question instead of only the mechanical, you want to know about the electromechanical or the thermal from previous, you can also ask me, or you can see through the our recordings from our previous in our YouTube channel, our previous webinar. So yeah, I think that's all for this simple simulation regarding the mechanical analysis. And now I'll pass this mic to Zulaika back for the for any further uh, to further our webinar here. So Zulaika, you can take over the screen.
Thank you very much, Arhan, for this informative webinar on mechanical analysis for BPM motor. I hope you have been enjoying the presentation so far. Before we move to Q&A session, I already launched a poll. Please select the appropriate response and click submit. Now it's time to address your question. Feel free to type your question in the chat features, which you will find at the right of your screen. We will do our best to answer as many questions as possible during this session. Does anyone have question regarding this topic? While we are waiting for question to come in, I like to remind our participants that sometimes it takes a moment for question to be formulated. Do not hesitate to ask about anything related to our discussion today.
So we have a question here from Imran. So it says, is this Ansys Motor-CAD limited to FEA only or can be used for CFD too? So my answer is this is limited to FEA only because if you want to do a CFD simulation, you can use you need to use a different Ansys product. What I can recommend is Ansys Fluent to use for CFD. Do you have any more question regarding Ansys Motor-CAD? If we don't have any more question, maybe Reka, you can wrap this up, this webinar.
Okay, Mr. Farhan. It seems that we might not have any question. But that's perfectly all right. Rest assured, if you do have any question later, you can always reach out to us via email or on social media channels. We appreciate you being here. We also encourage you to connect us with on social media to get latest information. Thank you all for attending. We hope you have learned and enjoyed this presentation. Have a nice day.
All right. Thank you, everyone. Thank you for attending.